17. If you have any noise-making devices, please tell them not to make noise, because nobody likes that. Our next speaker is Barry Warsaw, and he will be introducing us to a better async IO-based SMTP server. Please make him welcome.
Thanks. So I'm going to jump right into it because I'm going to be tight on time. This is one of my favorite quotes. I don't know how many people remember Jamie Zawinski, pretty famous hacker from the 90s and 2000s. This might be apocryphal, but yeah, so every program attempts to expand until it can read mail. Those programs which cannot so expand are replaced by ones which can. So that's clearly been like the defining motto of my career. So, you know, I am the project leader for GNU Mailman, and I've worked on the email package and other SMTP libraries, and I'm going to talk today about sort of a newish version of SMTP built on top of the async IO protocol. So what is SMTP? SMTP is the Simple Mail Transport Protocol, I'm also going to talk a little bit about LMTP, which is sort of a cousin of SMTP, where SMTP defines how to transfer email across an unpredictable internet. LMTP has fewer guarantees for delivery because it's usually to trade email with programs on the same host or across a local area network. So why write like an SMTP server? Well, one of the reasons is because you'd like to be able to test email clients. And there's lots of these, right? Almost every program sends email. And you'd like to have a nice framework for doing testing. Mailman is a great example of that. A message comes into Mailman, and it gets exploded out to hundreds of or thousands of recipients, and you'd like to have a nice little framework that you can make sure that you're sending the right number of emails, and they have the right format and things like that. Without all the baggage that comes along with like a big open source mail server like Postfix or Exim. You'd like to have something that's configurable in Python, so that you can do things like say, hey, I want to only accept email from certain recipients or for certain senders, and only if they're destined for certain recipients, and things like that. And it's just nicer to have something that's based in Python that you can just plug some things in and get the functionality that you want. You'd like to have a nice framework for doing experimental protocols. So there's SMTP. You may be thinking about extensions to SMTP, or you may be thinking about protocols that look a lot like SMTP, but maybe have some differences. And this provides a nice framework that you can experiment with. And finally, yeah, so I'm not claiming that AIO SMTP is production quality, but it's pretty good for small to medium sized sites. We definitely have some of our users are using it in production, so it can be done. I wouldn't run Gmail on it, but it has certain performance guarantees. So what is SMTP and LMTP, right? These are defined by RFCs. For those who don't know what RFCs are, they're internet protocols, and they're big legalese documents that explain exactly what happens on the wire. PEPs, for example, were modeled after RFCs, but sort of much more lightweight. And the thing here to recognize is that RFC 821 is the original SMTP standard, and it's 35 years old, right? So as much as we want to kill email, and everybody hates email, it's one of the oldest internet standards that's still in use today. In 2008, RFC 5321 was defined, and that's an extended SMTP, so it has more options and a few more commands. And that's really sort of the standard at which AIO SMTP is written against. LMTP defined in 2033, and there's lots of RFCs, both for the wire protocol and for the format of email messages. So I apologize in advance. I'm going to show you sort of what SMTP looks like on the wire. The text is small, but too bad. In this case, yeah, it's really small. But Everything in orange that you can't read is stuff that's going from the server to the client, and everything in a moment that's blue that you won't be able to read is stuff that goes from the client to the server. A few things to keep in mind. These are byte-oriented protocols, and originally, with the original RFC 821, they were 7-bit ASCII, right? So what's kind of nice about that is it's sort of human readable, right? Now, the extensions are able to handle 8-bit bytes and things like that, but I'm going to keep things simple for this discussion. The other thing to keep in mind is that all these lines end in carriage return line feed, and I'm not showing those for the most part. You'll see one small example where that shows up, just to keep things simple. The other thing to keep in mind is that many people who have seen these types of protocols should recognize this. When the server returns a response, you'll see first a numeric code, usually 3 characters, 3 numbers. And the first one, where you see a 200-level response, that's usually a success response. So when the client first connects to the server immediately returns a greeting, and that's the 220 greeting. And then the stuff after that is kind of helpful information, but kind of much more free form. The next thing the client does is it sends a hello command, and that's the first command that comes from the client to the server. And again, here you'll see a very similar pattern where the commands are 4 characters, usually in uppercase. Well, in SMTP's case, they're all in uppercase. And they may or may not have an argument. So in this case, the client is saying hello, and it's identifying itself. That's the host name of the client. And then the server comes back with the response, OK, it's a 250, so you know it's an OK, that command was accepted. And then the server is identifying itself to the client. The next thing that happens in the protocol is that the client says, hey, this is a message from a certain sender. And that's the mail from command, and the argument is the email address, which is the sender. And we usually say that this is the envelope sender, and that distinguishes it from the from header that you might see in your mail reader. As you'll see in a moment, we're not really concerned with what you actually read in your mail reader. This is sort of the on-the-wire protocol. So the mail from the envelope sender here may or may not be the same as the from header. They aren't required to be the same thing. So after the client says, OK, this message is from this particular email address, you can get one or many recipient addresses. And these are the receipt to commands. So we say, OK, well, you know who the mail is from, and now you know who the mail should be delivered to. And again, this may or may not be like the to or the CC headers in your email. The next thing that happens is the client says, OK, I'm ready to send you the data, right? This is all the stuff that you'd actually see in your mail reader, right? When you look at an email, everything that's coming in after the data is what you would actually see. And the server responds with a 354, and it says, OK, just send me a bunch of stuff. I don't really care what it is. But when you're done, give me a line with a dot on it, with a dot on the line by itself. And again, because you're not seeing the carriage return new lines in this example, but they do exist, and they are how the message is delimited. So now the client sends all the data. Whoops. The client sends all the data, and then it sends a dot on a line by itself. The server sends a 250, and at that point, the server says, OK, now I'm going to be responsible for the delivery of that message. Then, if it's a well-behaved client, it'll send a quit, and that's it. Lots of other commands that can happen, but that's the basic dialogue between the client and the server. Now, what's important here is that bit, the stuff that you see in your mail server, we're not going to talk about that today at all, right? That's part of RFC 5322, and that's really the responsibility of the email package in Python. So all the stuff that we're going to talk about today is the stuff in the green, and that's part of is defined by the wire protocol, RFC 5321. A couple of variations, as I mentioned. The original SMTP had the HELO as the first command to start the dialogue. With extended SMTP, they used a little clever trick, and they swapped the first 2 characters. So if you see EHLO, you know you're talking extended SMTP. And similarly for LMTP, they had yet another clever little trick. So LHLO, you know you're talking LMTP. So I'd like to give you a very brief history of like sort of how we got to where we are today. Originally in Python 2, in the standard library, you had this semi-asynchronous, but not really, kind of like a select-based loop libraries called async chat and async core. And it was a way to do sort of select-based I/O. And in 2001, or thereabouts, I refactored some code that I had in Mailman, and I put it in the Python standard library. And it's built on top of async chat, async core, and it's called smtpd.py. And if you open up Python 3.6 today, you'll still find that there, and it still works. The problem with that is that because it's built on async chat and async core, it's not very extensible, and it's really hard to understand. But it does work. When I was on the Launchpad project, I wrote this thing called Laser SMTP Test, and it's built on top of SMTPD, and it sort of adds some useful features for testing. And some of the ideas in Laser SMTP were taken into AIO SMTPD. Of course, in Python 3.4, along comes the async I/O framework. And so a guy by the name of Benjamin Bader took the first crack at porting SMTP onto the async I/O framework, libraries. And that actually informed in a lot of ways, it sort of provided the base for AIO SMTPD, which we wrote in April, started writing in April 2015. There's a bunch of people, some of the folks are here, and I'll acknowledge them at the end. We have a little Washington, D.C. Python hacking crew, and we got together and we're looking for an interesting project to work on, and we said, none of us know anything about async I/O, so hey, let's do something on async I/O, and somehow they listened to me, and I said, I suggested we write an SMTP server. So I want to talk a little bit now about some of the components that you'll find in AIO SMTPD. So the first thing you'll find are two classes that do SMTP and LMTP. They're separate classes, even though like LMTP derives from SMTP. But the SMTP class itself does both the traditional SMTP and the extended SMTP. There are two other classes called sessions and envelopes, and I'm going to get into a little bit more detail about those, but those basically are how state is collected during this entire dialogue. You can define handler classes, and the handler classes is how you can write some code to react to certain events within the protocol, and those events really are the commands and a couple of other things. But basically, the SMTP commands will call event handlers on the handler. And then the controller is an optional piece, and I've actually been able to refactor it and maybe get it into the standard library, because it's pretty generic. But that provides really nice start and stop semantics, and it runs the SMTP server in a subthread. So that makes it a little bit nicer for doing testing. OK, so sessions. The session is a class that maintains state related to the socket connection. So when a client connects, a new session object is created, and that lives as long as that client has a socket connection to the server. And it has things like the SSL details and the socket peer, a few other things, and it also has the async I/O event loop. That's on the session object. So its lifetime is from the point at which the client connects to the server until the point at which the client disconnects from the server. The envelope, on the other hand, collects state that's related to the protocol. So the protocol defines state transitions, and it says, when you see an HELO, you start to build up state. But, like, for example, you can get the mail from, you could get the envelope sender and a couple of receipt tos, and then the client could say, you know what, reset that dialogue. And if you see a reset or another hello, which is semantically equivalent to the reset, then the whole envelope is thrown away and a new envelope is created. So the envelope really maintains the state during the protocol. And as I mentioned, it has the envelope sender, the envelope recipients. It has two content attributes. One is the original content, which is always bytes. And then you can set the server up to decode those bytes into using UTF-8 into a string. That's optional. And if you do that, then the content, and it turns out that that's kind of handy to deal with. So if you set the flag and the client is well behaved, then the content attribute will be a string. But if you don't do either one of those two things, then it'll be exactly the same as the original content. It'll be a bunch of bytes. And some more options and things like that are maintained on the envelope. So the SMTP class itself implements all the verbs in the SMTP protocol as coroutines. And that's really nice because then basically the class itself has a single dispatch loop where it's reading a line of text or bytes, and it pulls out the command, and then it sort of it introspects itself to find a coroutine that matches that command. And if it finds it, then it says, OK, that's the implementation of that command. And we'll see a code example in a moment. It handles start TLS, although there's open discussions about that because we have some, the async IO doesn't really provide an API for doing start TLS yet, and it's been a little bit buggy to get that right. But it does handle start TLS, handles UTF-8, calls the event handler, right? It does have some hooks for doing exceptions because things can go wrong at certain points in time, and as I mentioned, it's extensible by subclassing. So let's look at an example. This is a little simplified, but it's basically how HELO is implemented. Now, the current, the version 1.0 of the library supports Python 3.4. So currently, you'll see things like the coroutine decorator and yield froms, but we're going to pretty soon drop 3.4 and adopt the new 3.5 syntax. So I'm just showing that here for simplicity's sake. So the important thing, of course, it's a coroutine, so async def, and then every method that implements an SMTP command has the same format for the signature. It starts with lowercase SMTP with an underscore, and then the command name, okay? And it takes a single argument. Now, as we saw earlier, the data command doesn't have an argument, and in that case, the argument would be none. But the hello requires an argument, so you can see here what it's doing is saying, okay, well, if there was no argument, then that's a syntax error. And you can see how we're pushing the response back to the client. And here, we're using a string just because we don't want to have to put a B in front of everything, but the self.push will turn it into a bunch of bytes. And obviously, that's a synchronization point, so you see the await there. The self.set reset state, that's where we get the new envelope. And then at the line that says status equals await self.undercall handler hook, that's where we're calling into the handler to give it a chance to respond to the hello command. But it's optional, so handlers don't have to respond to every single command. And if they don't, then what's going to come back from that hook is this singleton called missing, and then the built-in command will just do the default behavior. The important thing to remember here is that if the handler does want to respond to the command, it has the responsibility to do all that default behavior. So where we're stashing away the host name, the handler would have to do that, and it would have to return the status code. So here's how you would add a new SMTP command. It's pretty simple. You can see all we have to do is derive a new class, and we're going to add a command called now, capital N-O-W. And we can take an argument, but it's optional. And if it's an argument, then it has to be capital UTC, in which case we'll return the UTC date. If there's no argument, then we'll return the local time. And anything else is not accepted. It's a syntax error. Don't worry about the now.replace. That's just to make things a little prettier. And then we return the status code. So how does that actually look like on the wire if you were to type this into a Telnet client, right? Here we're actually connecting to the host. It's listening on localhost port 8025. And you can see we get the greeting, and then we just type capital N-O-W, and we get the current time. We wait a couple of seconds. We do it again, we get another local time, and now if we give the UTC, we'll get the actual UTC time. If we type now and then, which is a syntax error, you can see how we get the syntax error. So that's how what happens on the wire is translated direct, or is mapped directly to the method, the coroutine that implements that. Switching gears a little bit, I'm going to talk about the event handlers and what they look like. So the event handler is just a class, and you instantiate it, and you pass it to the server. The server requires an event handler. There's a bunch of default ones built into the library, and you can just use those. There's a sync one that basically doesn't respond to anything. But if you want to respond to a particular command, then they're going to look like this. They are coroutines. So they start with the string 8 handle underscore and then the name of the command. And they all take at least 3 arguments. So they all take the server, which is the SMTP instance, the instance of the server class, the session, as I mentioned, and the envelope, as I mentioned. And they may take additional arguments depending on the actual command. So of course, as I mentioned, the handler is, again, it's introspected for the methods that would respond to the commands. They have to be coroutines, and they're responsible for all the behavior if they exist at all, and also for returning the status code. So here's how we would implement, for example, a hello counter. We just want to count the number of times we've seen the client has given us an HELO. Or actually, any client has given us an HELO. We're going to implement this class. It's real simple. It doesn't have to derive from anything. Everything's duck typed. And we're just going to initialize the counter to 0 in the class definition. And then in the handle, so here you can see we have async def handle under HELO. And we're getting the argument. You can see we get the server session envelope, and we're going to get the hostname argument. Since the handler is going to respond to HELO, it has to implement stashing the host name, and then it's just going to increment the counter and return 250 OK. So this is roughly how you might run it. We're going to instantiate a single counter class, and then we're going to instantiate the SMTP class. And we're going to do some magic to run it for quite a while, and eventually it's going to exit, and then we just print the hello counter, and we've seen how many hellos that server has seen. It's pretty straightforward. So basically, any SMTP command can be implemented, can be responded to by an event handler. But there's only one event handler class or instance per server. So if you want to respond to a bunch of things, you'll have to implement a bunch of these handler methods. The controller is an interesting class because it runs a server in a subthread, and it provides start and stop semantics. So there's basically two methods that you'll use. One is to start the server, and one is to stop the server. And of course, you pass in the host name and the port that you want it to listen to and stuff like that. You also can override the factory method. There's a default factory method that creates a default SMTP server with a default handler. But you may want to have different handlers or pass in different options to the constructor, and you do that by overriding the factory method. Now, what's really interesting about this is that if your test suite, like let's say you're testing an SMTP client, your test suite may have fixtures. And when your fixture starts up, you want to create one server, and when your fixture ends, you'd like to just stop that server. And the controller provides a nice way of doing that. So let's say you're using unit test. So in your setup, you can create a controller and pass in a server instance, and then just say, OK, in the setup, I'm going to start the server, and in the teardown, you can stop the server. And then it doesn't block the progress of the rest of your unit tests. So that's pretty handy. And as I mentioned, this is fairly generic. So it's not so much tied to SMTP. I'm kind of hoping that we can get it in the standard library. You can actually run SMTP, AIO SMTPD on the command line. We used to have an entry point that was SMTP or SMTPD, and we thought that that was a little too generic. We didn't want to like claim user bin SMTPD. So we renamed it. You can, of course, run it with the -m option to Python 3. This is only Python 3, of course. And that's how you would do it. Or you could just run if it was installed, if the entry point was installed on your path, then you could just say AIO SMTPD and then the same arguments. The -n is for running not as root. So if you're running it as your own, so if you run it as root, then it tries to reduce the privileges. And obviously, you can't do that unless you're root, so that's why when you're just running it as yourself, you would patch the -n to say, don't try to reduce privileges. The -c allows you to name a class that's importable on your Python path as the handler class. And they can take arguments. So many handlers may not take arguments, in which case you just patch -c and then the name of the class or the path to the class. But if you want to pass arguments, the way you do that is to implement this class method on your handler class. And really, this is just like super simple. This just takes a bunch of strings, which are passed in from argv, and it converts it into whatever data types your handler class requires. So convert is not something special. That's sort of like a add your code here kind of thing. But that's the general look of that. I'm doing pretty good on time. So that's essentially SMTP, AIO SMTPD. The documentation is really good, I think, at least I hope. So you should be able to, with like a little bit of reading and maybe this video, get into it pretty easily and get your own implementations going pretty quickly. Definitely want to give some shout outs. As I mentioned, Benjamin Bader kind of did the first attempt at this and informed a lot of the work that we did. There's the DC hacking crew. Jason Coombs, I think, is not here. Andrew Kushling is not here. Eric's here in the front row to heckle me. And David Murray is, a fan. Oh, there he is. Okay, yeah. He joined us remotely, and, if you have any email questions, well, I won't say that. That's a cruel thing to do, but but David's a great guy. So, and then Konstantin Volkov and Matthias Rav are two contributors. I think one of the other one is actually running this in production. So, so it's actually really used, and they've helped out a lot, and lots of others. So, we're on GitHub, right? And I definitely want to, we're on Read the Docs and GitHub. So please come and contribute. And I think I'll stop there, and maybe we'll have a couple minutes for questions.
Everyone, please thank Barry. If there are any questions, please come up to one of the microphones in the aisles.
Hi, great talk. Obviously, quick question. The discussion here is on the server side. Is there a client-side asynchronous mechanism you recommend, having had to just go through some weird hoops?
Yeah, so we don't have a client side. That would be kind of an interesting to add. Did you have any thoughts? I mean, we use the SMTP lib in the standard library.
I had issues with that because it blocks if your server doesn't respond because of the wonderful attempts to keep you from hacking stuff. So we've had to create a microservice and just kind of queue things into a microservice to do it. And that feels kind of like, eh.
Yeah, I think SMTP lib would be a good candidate for async IOing, if I can. Oh, it does. You want to go to the microphone so people can hear you.
I just want to say there is an asynchronous client SMTP library. It's pushed on PyPy. I don't recall exact name, but you could Google it quickly. And sorry, personally, I didn't use it, but I know it exists.
Awesome, cool.
It exists, but it's one of those ones out there that has very few followers and that kind of stuff that made me question, if I see something like this, it's by people, everyone's using it. It's easier to say, yeah, use it, as opposed to I don't know, someone just push it.
One more question over here, please.
If you used it, though.
Thanks for the talk. I was curious, the handler seeing async in front of it, and I'm sorry if I don't quite understand how this works. I just got introduced to Python async a couple hours ago. But that makes me think that it could be called with await somewhere else. So maybe inside that function, you might do something that would say, tell the event loop, hey, I'm going to wait, do something else for a while. But the example that you gave was just maybe two things and then return. Can you give an example of something that would make that where it might hand off to the event loop?
Yeah, so like, for example, you might want to, at the point at which you end the data command, you've now got the text of the message, and you may want to hand that off to like some spam detection or something like that, and that's going to take a while. So you could just await out to to that. There's things like that I think you could do. There's other ways to say like when you get the recipients, you may want to await some check on whether those recipients are valid or not, or you actually can assume responsibility for those recipients. So that's the kind of thing that you would do in a handler method.
Cool. Thank you.
Yep. Cool. Thanks.
Everyone, please thank Barry.